Hi class, this is 18.6. We're going to be talking about angles of elevation and angles of depression. And angles of elevation and angles of depression are following a line of sight usually. When we're outside in nature, we can indirectly measure things using triangles that we create. And these triangles that we create we're not drawing them out in the parking lot or in the sand or wherever we might be, but we're creating a 90-degree angle with legs and a hypotenuse of a triangle that we can use that triangle to measure things that it's an indirect measurement that we're wanting a measure for, but we can't actually take a tape measure to. For instance, if you are going on a hike and you come across a river and you want to measure the length of the river, how far across it is, so that you can determine whether or not you can traverse it safely, you would be able to create a right triangle from where you're standing at the river, perpendicular or parallel directly across from the river. You can create a line, and it's kind of an imaginary line, so to speak, but you would create a line across the river, and then you would measure out maybe 5 feet to the right, and then make that side a triangle over back to that original point that was directly parallel with the river on the other side of the river across from you. And you can create an angle and that 5-foot measurement that you need, and with that angle and the measurement that you did find on the side of the river that you are on, you can create this triangle. I can maybe draw a picture to see if that might help you a little bit. So here you are, here's your river. I hate it when it does that. So that's your triangle. Whoops. Does that make it go? It's a right triangle. And I meant for this point to be at the edge and this point to be at the edge and this right here to be a straight line across the river. And I'm going to just draw it right here because that's jumping. I forget it jumps over there for some reason. But here you are standing. You measure 5 feet out here to another point, and that's one side of your triangle. And then you can take a perpendicular to this other side parallel on the river to you and draw a line over to this point 5 feet to the side of the river with you. So once you have that triangle right there, if you measure this angle, so you are here and you take a line of sight, really, that's a line of sight over to the side of the river where it was directly across from the original point. And with that point, maybe you can see that that's a 30-degree angle, and you can use that information to figure out what that height is, or the length of the river. I'm going to call it a length of the river across it, so that you can determine whether or not it's passable. So here you have a 30-degree angle. You have a tangent scenario. Tangent of 30 degrees equals length divided by 5, opposite over adjacent. And so that length would be 5 times tangent 30. So you can pull out your little calculator on your phone, and you can do 5 tan 30, and it's 2.9. And I don't know if you did that in feet, so 2.9 feet, and you could say, oh, that's certainly passable. And I made that up and made up the numbers, and I obviously didn't make up too great of numbers because obviously you could tell if that was 3 feet across. But otherwise, it would have been a better example if it were 30 feet across, because then you can make a great determination of whether or not you could swim that far. But that's basically what we're doing in nature, and we have maybe the imaginary side of the triangle that's 5 feet down. We're not going to draw it. We're just going to go 5 feet and know where that is, and then mark in our head something that we see across from the river that's directly across from us, and then use whatever we need to come up with that angle in order to help us come up with an approximate distance across. And that's what we're going to be talking about today. But that one was across. The majority of what we're doing is looking up to things, like on the top of a cliff, and what's the height of this cliff? Or if we're up on top of the cliff and we want to come down, look at something down on the ground and determine how far down that is, and if our rope's long enough, or to make it down safely. And we call those angles that we create, the angle that we created with the river is similar to it. But we need one angle and one side measure, and we need to make sure that we find those that we can find and determine ahead of time. But we call them angles of elevation if we are looking up to something, and we call it an angle of depression if we're looking down to something. But again, we're creating an imaginary right triangle, and we're finding an angle and a side that we can find in order to come up with the measurement of something that we can't normally come up with any other way. We call it indirect measurement, using trigonometry to measure things indirectly. So angle of elevation, we're going to start with, and what you have in your picture here is a person standing there, and he is standing and he's looking upward. If you notice, it's up that he's looking up toward the tippy top of that lighthouse, and you could use that angle right in there that you see, called an angle of elevation, from your line of sight. I like to call this the line of sight. Actually, it's the horizontal, I guess, line of sight. And then you have the other line of sight, and that creates an angle in there that you can actually come up with and use in your trigonometry to find maybe the height of the lighthouse. But as long as you're looking up, it's an angle of elevation, like the picture there. So what we do if we're given a problem, a lot of times it doesn't tell you, use the angle of elevation. So that's kind of hard. We don't know exactly what the angle of elevation necessarily is, but they'll tell it to you, and generally they'll say it's an angle of elevation, but a lot of times they don't. So you have to determine, well, is somebody standing on the ground and they're looking up, then they use it, or an angle of depression is if you're looking down. But in this case, it tells you the angle of elevation from a kicker's foot on the football field to the top of the goalpost bars is 17 degrees. So the trick here is you got to draw the scenario so that you know what the sides are and which sides are involved, so you can set up the appropriate trig function like sine, cosine, or tangent, as well as the ratio with your x in it. But you have a dude here, or a girl, I don't know. We'll give him lots of hair. And then he has a football that he's going to be kicking. So here's this football, and he's going to kick this football, and the angle of elevation to the very top with this football and to the goalpost here. So that's the angle of elevation. Again, it's from the kicker's foot right here to the top of the goalposts right here. So foot is the line of sight, basically, horizontal line of sight, parallel to the ground, so therefore creating the bottom leg or the side leg of that triangle. And then you have the hypotenuse is going to be the line that the football travels once he kicks the football. And that angle there is 17 degrees. So we have to be able to set that up with the angle in it, and then put the appropriate information into that triangle so we know which side we're trying to solve for and which side we already have information for. So the side we're given information is right here, standing 130 feet from the base of the goalpost. So right here where he stands to the base of the goalpost in there is 131 feet. So that's important information right there. And then we're asked to find how tall the goalpost is. I like to write height, H for height. So that's what we're asked to find. Now, once you have that triangle set up and you know where everything is, then you can look at it and determine which of the three trig functions we have a setup for, and that is going to be tangent, because we have an opposite side and an adjacent side, and OA is TOA, tangent, opposite over adjacent. So we can fill in our equation, tangent of 17 degrees. Remember, angle always follows the function tangent, is equal to h over 131. And once we have that, we can solve for h and then place it in our calculator to come up with the height. So we're going to times by 131, both sides. And we get our height is 131 tangent 17 degrees. And the calculator, I'll just put it in, 131 tangent 17 is 40.1. And is that feet? I believe it's feet. All right, so 40 feet. He's standing from the base of that goalpost. All right, next up, this example is a little trickier because it involves two different scenarios. It says at a point 125 feet from the base of a building, and luckily they give you this little picture. So right here to the base of the building is 125 feet. Okay, and then the angle of elevation to the third floor, so that's right here. Here's your third floor. All right, so from there to there, this angle going up to there from the horizontal is 22 degrees. Okay, so 22 degrees. And then the angle of elevation to the 10th floor, so this one's 22, but there's one from here, and I'm going to stay all the way up to this 10th floor here. That one is a total of 53 degrees. Okay. How much higher is the 10th floor than the third floor? So what they're really asking for, I'm going to do it in red, is this right here. They want to know how tall that is from the third floor to the 10th floor. Basically, what we'll have to do, and I'm going to try to outline these in a color, different color so you can see. First, we need to find this height right here, the height to the third floor. So we need to find that value right there that takes us from there to there. We can find that because we have a right triangle and we have an angle 22 degrees, and we have one measurement of a leg, 125 feet. So we're going to use that information first. Okay, and we're going to do tangent because this is opposite and this is adjacent, so that's tangent. Tangent of 22 degrees is equal to opposite x over adjacent 125. So x is equal to 125 tangent 22 once you solved. Okay, once we've got that, that's going to be this amount right here. Then we're going to, probably ought to use like blue. Then we're going to find this triangle, because again, it's a right triangle. We have an angle, 53 degrees, and we have a side that's 125 feet long, and we can look for this height here that is the total height from the ground up to the 10th floor, and that we'll call y. Next, we're going to do that, and it's tangent 53 degrees, because that's the whole angle from the base, from the ground, the line of sight, horizontal, up to the top of the 10th floor. And it's 53 degrees, and that's going to equal y over 125 feet. So y is going to equal 125 times the tangent of 53. Okay. Now, that's pretty awesome. And I'm going to just quickly come up with these values. So in my calculator, I'm going to put 125 tangent of 53, and that's 165.9 feet. And then 125 tangent 22, and that's 50.5 feet. So here is 50.5, and the whole thing is 165.9. So of course we're going to subtract them, and I'm just going to put them in my calculator and subtract. So I'm just going to extract those numbers so that it's as accurate as possible, and I got 115.4 feet. All right, is how far it is from the third floor to the 10th floor. All right, now I'm going to go ahead and do angle of depression next, so hang tight, come up, listen to part 2 next.